you make a silly mistake. So anyway, but I want to be there to answer any questions that you may have, okay? So let's jump into 3.3, long division and synthetic division. So here we go, starting with long division. If a polynomial is reducible, we can write it as a product of factors such as, and it's given right here, f of x equals x plus 1 times x minus 4 times x plus 5. Now you guys know that once it is written in factored form, we can apply what we call the zero product property. So I'll write this down, zero product property. And every factor that you get in that broken down polynomial, you can set equal to 0 and solve, and that value will be your x-intercept. Okay, so I'll take the first factor, x plus 1, set it equal to 0 and solve. Go ahead, that's fine. And subtract 1 on both sides, and you get -1. So if we do that every single time, add 4, both sides. Okay. So everything that we just did here in this particular step is what you guys have been doing in section 3.2. I've been giving you functions in standard form, and you had to convert it into factored form so that you can use the zero product property that gives us the go in the factor theorem to be able to solve for our x's. Okay, just out of curiosity, what is the multiplicity of x equals -1 going to be? 1. Where did y'all look to find that? How did you know it's a 1?
Is it the opposite of
So the opposite, what you're thinking is taking the factor and solving by doing the opposite, right? How did y'all know the multiplicity of -1 is 1? Go ahead, JC. The exponent of the factor. Very good. So that invisible 1 right here tells me that x plus 1 showed up 1 time. So that graphically means it cut right through the x-axis, right? Y'all remember that stuff? Okay. Okay. And so it so happens that each one of these has a multiplicity of 1, 1, 1. Okay. All right. So if a factor, if a polynomial cannot be reduced, it's called an irreducible polynomial. But our goal is always to completely reduce. Okay. Now here is the goal of why we are using long division. So come with me to the part that says the hard part. The hard part, however, is actually finding ways to factor higher degree polynomials. However, if we know one root of the given polynomial, we can try to use long division to find the others. So here's an example of a polynomial that factoring right off the bat is not going to help us. Okay? So you guys are going to notice that you have 4 terms here. So automatically when we see 4 terms, we are supposed to attempt factoring by grouping, which means that we kind of split that four-term polynomial into 2 parts and see if we can factor. Now, before we proceed, is there a GCF for that polynomial x cubed plus 4x squared minus 5x minus 14? Other than 1, is there a GCF? There isn't, right? We have a 1, a 4, a 5, a 14. We have a kind of a mixture of even and odd coefficients, and there definitely isn't an x in every single one. So the only GCF is 1. It doesn't help us, okay? So let's factor by grouping. What is the GCF for the first 2 terms here?
X squared.
All right, so x squared. What's left over?
X plus 4.
Good. Now we're going to go to the other side. What's the GCF for these 2? Okay, so what number is that? So positive or negative? -1, good. And what is left over?
5x plus 4.
All right, so what's the problem right here with this factoring grouping? Very good. What's inside these parentheses are supposed to be the same to even allow us to proceed. So here is where long division helps. Okay, now what I'm going to do for you guys is I will provide you with a root of the polynomial I'm asking you to break up, okay? In honors geometry, not geometry, in honors pre-calculus, we force students to use this particular theorem to find all possible zeros. We're not going to have you guys do that. We, the teacher, will provide you with one. You have to go find the others. So if I give you one, you will be able to do long division to be able to find the others, okay? So here's what I mean by that. We're going to factor, if we move down here, we are going to factor this polynomial that we just tried to factor here. We're going to actually long divide. I don't know why I'm saying factoring. We're going to long divide so that you can see what you do. So my problem is x cubed plus 4x squared minus 5x minus 14. I wasn't able to factor it, okay? But I did tell you guys that x equals 2 was a root. And because it's a root, what I did was rewrite it as a factor, okay? So x equals 2 as a root can be rewritten as x minus 2 as a factor, okay? Because we do the opposite. Now, before I show you the technique on how to do long division, I want you to take a second and I want you to take a trip down memory lane and I want you to long divide 2,685 divided by 3. So take a moment, put it in a corner somewhere, and I want you to do long division by hand. Write out the process. I don't care about the answer. I care about the process of long division. Because the process of long division here is what you're going to use with your polynomials. All right, so 3, does it go into 2? No. 3 go into 26. All right, so we put the 8 above the 26. Then what did you do? All right, so first thing she did, we put the 8 at the top and then you multiplied, right? You guys got it? So you write it above and then you multiply. Again, I don't care about the answer. I'm trying to get you guys to understand the process, because the process is what's going to carry over to the dividing of polynomials, okay? So after you multiplied, what did you do? Arithmetic.
Minus.
You minused, okay? So we're going to subtract. So I put a minus here, and 26 minus 4 is a 2, and then bring down the 8. Good. So I brought down the 8. And then what did you do?
9.
Okay, 3 goes into 28 9 times. Then what did you do? What did y'all do?
28 minus 27.
You multiplied, okay. And then what did you do? You subtracted. And then what did you do?
Bring down 5.
Bring down the 5. And not to overly frustrate you. So do you see the process that kept doing? You guessed the number, you multiplied, you subtracted. You guessed at the number, you estimated, I shouldn't say guess, you estimated the number, you multiplied, you subtracted. You estimated the number, you multiplied, you subtracted. You guys got me? Okay. So I want you to take that same technique and you're going to do it again, but we're doing it with the polynomial. We're going to take the x minus 2 factor and we're going to divide it into x to the third plus 4x to the second minus 5x minus 14. Okay. Now, when you guys are setting these problems up, there's one thing I do need to harp on, okay? Inside and outside your dividend and your divisors, okay? make sure these are in standard form, and make sure if you are missing a term, you put it as a 0. And what I mean by that is I need you to look at the exponents. If the highest exponent is a 3, every single term has to decrease by 1 all the way to 0. 3 showed up, 2 showed up, 1 showed up, 0 showed up. You actually have to write every single term. So here's what I'm saying. If this happens, let's say I gave you a polynomial that looked like this. Let's say I gave you negative 9x to the 5th plus 2x cubed minus 4. Did every single polynomial show up after the highest exponent? Did every single term show up after the highest exponent? No. Which ones were missing?
4 and 1.
Okay. Anything else? Remember, if you start with a 5, I have to see a 5, 4, 3, 2, 1, 0. So you would have to rewrite this as negative 9x fifth plus 0x4 plus 2x cubed plus 0x squared plus 0x minus 4. Do you see what I'm saying? You need to put a placeholder for every term that is missing in your polynomial. Okay? You guys got me? Okay. So the highest here was a 3. 3, 2, 1, 0. Nothing is missing, so we don't have to put a placeholder. Okay, so here's how you do the questioning technique. You are dividing by x minus 2, but I need you to focus only on the x when you are trying to figure out x times what goes into this polynomial. Okay? So, x times what will give me x cubed? X squared. So the answer that you said goes up here above the x squared term. So I'm going to put x squared right here above 4x squared. Okay? Now, once you guys would write the number, like number 8 up here, that's my x squared you guys multiplied, right? So you're going to take this x squared and you have to multiply by everything here. X squared times x, x cubed. X squared times minus 2 is negative 2x squared. Anytime you multiply, you are going to notice that these two terms are going to be identical at first. Okay? They have to be identical. After you guys wrote the number down, did you guys not subtract? Subtract means take the opposite. So if I take the opposite with this first term, this term has to switch. So it becomes plus. Do you see that you have x squared times x is x cubed, x squared times negative 2 is negative 2x squared. Are you with me?
Yeah, I get you.
So now you're going to subtract. So if I put a minus out here to this, this has to switch because I'm distributing a negative across. I can't just put a negative in front of the first term and not do it to the next one.
Oh, so in order to add the subtraction, you have to multiply the whole thing by -1?
There you go. Yes.
It's the first time I've ever heard that.
Mm-hmm. All right. So x cubed minus x cubed will disappear. A 4 and a 2 makes a 6x squared. And now you bring down your next term, minus 5x. And now we're going to repeat the process. So now you focus on this. I'll wait. I see you guys still writing. Okay? All I did was add vertically. Okay? These terms, the beginning terms, will always disappear. Okay? As you will see again in the next line. Okay? And then you just combine vertically. So now we do it again. X goes into 6x squared how many times? X times what gives me 6x squared? 6x. So I'm going to come up here and put my answer. Since you said 6x, that's a positive, so I'm going to put plus 6x. You're going to multiply again. 6x times x is 6x squared. 6x times negative 2 is negative 12x. Notice they're identical. They always have to be identical before you distribute your negative. So far, you with? So now let's distribute. If I make this a negative so that this cancels, this negative has to switch signs. So now these disappear. What's a negative 5 and a positive 12 make? A 7 is correct. So 7x. And then the next number comes down, minus 14. And then you do it again. You look at the yellow x, and you look at this new line. X times what gives me 7x? 7. You didn't say negative, so I'm going to put plus 7. So 7 times x is 7x. 7 times negative 2 is negative 14. They match. Okay, they always have to match at first. Then force them to cancel by distributing by a negative and changing all the signs. That becomes a 0. That becomes a 0. So in this case, my remainder is 0. So what I found out is that when I divide this polynomial by this, the answer is x squared plus 6x plus 7. Okay? So what you're saying is this times this gives me the polynomial. Okay? Does that kind of make sense? I'm going to give you guys one to see how you will fare doing it on your own. Okay, so on this one I'm putting some placeholders. So on this one, the x squared and the x term were missing. So I'm going to give you about 3 minutes. How about working this one out on your own? Let's see you ask the questions on your own without me talking. X plus 4 goes into 27x cubed plus 0x squared plus 0x plus 64. All right, 3x goes into 27 9 times, and we're missing 2 x's. So that's 27x cubed plus 36x squared. So I'm going to subtract here. So this here is going to become a minus. So 0 minus, so that's 36x squared plus 0x. Is everybody good there with me on that one? I hope. All right. Then we are going to go 3x into negative 36 is negative 12x. So that's negative 36x squared minus 48. So I have to switch it and switch it. So 0 and 48 makes 48x plus 64. And 3 goes into 48 positive 16 times, so 48x positive 64. So I have to switch. This has to switch to minus. So 48 minus, all that turns 0. All right, so 9x squared minus 12x plus 16. And I so apologize for all that mess. Okay? All right, are we good?
Yeah.
All right. Okay, so that's long division. Will it always be 0? No, it won't always be 0. So I will show you what you do when that happens. But let's jump to synthetic division, which goes by super fast. So if you turn over to the next side, another shorthand method to dividing polynomials is called synthetic division. Okay? Now, synthetic division does have its limitations. Okay? So has limitations. So that's why it's not used as often, but it is the preferred method by students and by me, by people, because it's so much faster. Why is it limited? Because synthetic division only allows you to divide by linear factors. And what I mean by linear factors is that you can only divide if you are dividing by an x minus r factor, okay? Which means only if you're dividing by x plus 2, x minus 2, x minus 5, x minus 6, and so forth. You can only divide by linear factors to use synthetic division. So for instance, the problem you just did, okay? I can use synthetic division to divide this problem because that's a linear factor. I couldn't use this one because that coefficient of 3 is a problem. Do you understand? It has to look like x minus an integer or x plus an integer. Does everybody understand? That's the only time you can use it. So if you have something, anything else other than that, you have to use long division. So here's how to do this really quickly. Okay? So we are going to set this up. So I want to divide x cubed plus 4x minus 5, this whole thing, divided by, what am I dividing by? The 2, x minus 2. So long division, this is what it would look like. X minus 2 goes into x cubed plus 4x squared minus 5x minus 14. But I want to show you guys how to do it synthetic division. Okay? So synthetic division, we're going to write it underneath. So here's how it looks. The first thing I want you to do is, if you had it a long division way, I need you to find what the root is. What is the root of x minus 2? 2. All right? Whatever that root is, that's why they always want you to do it in linear form, because you need to find the root. You are going to put it in a backwards L. So in this backwards L, write the number of your root. So the root goes inside there. Okay? The root goes in the backwards L. Now, after the root, right here on the same row, you are going to write the coefficients of each term. And if you skip a term, you've got to put a 0. Did we skip any terms here?
No.
No. What is the coefficient of x cubed? The coefficient, not the power. The number in front. An invisible 1. Yep. What's the coefficient of 4x squared? 4. So leave a space. Coefficient of x.
5.
Okay. Bring the sign down. -5. And the coefficient or the constant? -14. Very good. So make sure it decreases. 3, 2, 1, 0. So we've got them down there. Okay. Leave a little bit of space, and I want you guys to draw a bar. So leave some white space here because you're going to write something in there. So that's how you set it up. Okay. So these are this is being divided by this. All right. Now here's how you start. The first number, whatever it is, bring it down and write it underneath the bar. Okay? Drop down that first coefficient. Once you drop that coefficient down, you're going to take this number, the root, and I need you to multiply. So I'm going to put multiply here for your notes. Multiply this number by this number. And the answer you get, I need you to put it right here above this line. So 2 times 1, we write the 2 right here. So 2 multiplied by 1 and put the answer above here. When you write the answer, I need you to add vertically the numbers. What's a positive 4 and a positive 2 make? 6. You are going to repeat the process. Now, take the 2 now and multiply it by this one. What's 2 times 6? Go up here, put the answer. 12. Then you will add vertically. What's a negative 5 and a 12 make? 7. Then repeat the process. What's 2 times 7? 14. You will add vertically. When you reach where you can't go any further, put a forward-facing L around that last number. That is your remainder. Okay, that is your remainder. You actually are done. Now I will show you how to write the answer. Okay? What you're going to do is you look back at your previous problem. Your previous problem started with x cubed, right? And you divided x cubed by an x, so that means the first term has to be always 1 degree less. What's 1 degree less than x cubed? X squared. That answer you got here is the coefficient of your x squared. So if this was x4, this is for x cubed. If this is x10, this would be x9. So it's always going to be 1 less. So this is going to be 1x squared. That's a positive 6. So you're going to put plus 6x, and you just decrease. After x, that's a 1. This has to be the 0 term, which is my constant. That's my answer. And you're done. Okay. All right, that's your last problem. So I'm going to show you. So the question is, what if your remainder is not a 0? Well, here is the example. So I'm going to show you how to write that out. So I want you to do this one. Notice that on this one, you guys need to put a placeholder. And once we finish this problem, we're done with our notes. Okay? So do this one by synthetic division, please. 2x cubed plus 6x squared plus 29 divided by x plus 4. Okay? So go ahead and set it up and do the Alright, if you're ready to look to see if your numbers match with mine, look up. Okay. Now notice on this one you do have a remainder other than 0. So I'm going to show you how to write the final answer when your remainder is not a 0. But let's first write out the polynomial. What would be the first term of this polynomial? What is going to be the power of the first term of this polynomial? It's a squared, a 2. Very good. So 1 less than the original, right? So this is the coefficient of that first term. So 2x squared. And you just keep going down. Okay. Now, when you get, over here, we stopped and boxed it because the remainder was 0, but this remainder was not a 0. What you're going to do is you'll just put a plus and put that remainder as the numerator of a fraction, and you're going to put what you were dividing by, the x plus 4, in the denominator. So the remainder goes in the numerator, what you were dividing by goes in the denominator, and this will be your final answer. Why was it -4 here? Because you always need to find the root. And finding the root of a factor means you set it equal to 0 and solve. Okay, so you have to always set it equal to 0.